two variance. Okay? So again, for your test one, is just include until confident interval difference between two population. Start from the first chapter lah. Kita ada, we have maximal likelihood estimation, method of measurement, and then how you want to verify whether that one is unbiasedly estimator. Okay, and then we use the Kramer-Rao lower bound to compare the variance and then find uniformly minimum variance unbiased estimator. Okay, so then we proceed for this one. We have a confidence interval for a single population variance. Okay, so that's mean population variance that we have here is the sigma square. So sigma square is denoted as population variance, and then you have sample variance is S square. Okay. So again, it's quite different from your first year statistic. Okay, first year statistic, we just have only one formula that we need to consider, but this one is depend on two cases. Okay, so it could be either case one, which is mu is a known number. Okay, and then we have another case, mu is unknown number. So when you have a mu is a known number, so you don't have to estimate your mu. Okay, but case variance sigma square is unknown. Okay, and then the other case, you have mu is unknown number. Mu is unknown number. So that means we need to estimate parameter mu, and at the same time we need to estimate your population variance. Okay, so let us refer to the first case. So this one is mu is a known number. So again, we have a random sample. You have x1, x2, Sn. Okay, a random sample taken from a normal distribution. So you have mean mu and also variance sigma square. Okay, and then if we have the MLE, okay, you already estimate. Let's say if you have a normal distribution, so normal distribution, you have, let's say if we have x is normally distributed. Okay, so in the first week, we already estimate the parameter for mu and also for your sigma square. When we estimate your parameter mu, so normally we have mu heat is equals to x bar, and then you want to estimate also your sigma square hat. Okay, so sigma square hat is depend whether we have this one lah, kita ada 1/n summation xi minus mu. Okay, so ini dia punya standard lah. But again, let's say if we have your parameter mu is unknown, so that's mean we will replace your mu as your x bar. So you will have 1/n summation xi minus x bar square and so on. Okay, so again, so this is your MLE for sigma square. So sigma square hat is given as 1/n summation xi minus mu square. Okay, so recall back that I already mentioned the relationship between standard normal, okay, standard normal, and also chi-square distribution. Okay, so when you have a standard normal distribution, normally we will write your z is equals to x minus mu divided by sigma, right? So here what we have is, let's say, katakanlah so let's say you have w x minus mu over sigma. Okay, when we square root, okay, let's say you have v, this one altogether, x minus mu over sigma square, it will become a chi-square distribution with degree of freedom 1. Okay, why degree of freedom is 1? Because you only consider a single random variable, which is your x. But if you have your summation, okay, so let's say lah, I just put here, katakan y, y is equals to summation xi minus mu square over sigma square. It will become a chi-square distribution, but with degree of freedom is 1. Okay, so chi-square distribution with degree of freedom is n lah, dalam this case is n. So in this case, for chi-square distribution, normally your mean expected value of y is n, your variance y is 2n. So ini dia punya properties dia. So if you have a chi-square distribution, the properties is your mean is n, your variance is 2n. Okay, given that your y here, summation xi minus mu square over sigma square is distributed as chi-square, degree of freedom n. So let's say if you have a single random variable, so that means your mean is 1, your variance is 2. Okay, when you have your n is equals to 1. Okay, so itu properties for chi-square distribution. So you have y equals to summation xi minus mu square over sigma square is distributed as chi-square with degree of freedom is n. Okay, so now you want to construct your confidence interval for sigma square. So sigma square here is unknown parameter. Okay, sigma square is unknown parameter. So you need to estimate your sigma square. Okay, again, your probability, you need to find probability 1 minus alpha. So chi-square distribution, if you recall back or you can refer to your stats table, okay, there is the curve. So for chi-square distribution, it is called as a skewed distribution. Okay, skewed distribution, so that's mean lebih kurang lah ya, pencung. Okay, so you want to find probability 1 minus alpha. Okay, it's a skewed distribution. It is positive skewed lah ya, positive skewed distribution. So that's when you want to find probability 1 minus alpha. So it should be between chi-square alpha over 2 and also chi-square 1 minus alpha over 2. Okay, katakan let's say I put here italic V, okay, for degree of freedom. So you have probability, you want to find probability between chi-square 1 minus alpha over 2 V less than chi-square alpha 2. Degree of freedom V, probability is 1 minus alpha. Okay, so now we already have your Y. Okay, Y here is summation Si minus mu square divided by sigma square. So kita replacekan Y. Kita nak dapatkan dia punya probability dia between the lower limit and also upper limit. The probability is 1 minus alpha. So when we replace Y, so it becomes chi-square 1 minus alpha over 2. Degree of freedom n. Okay. So this one we replace xi minus mu square over sigma square less than chi-square alpha over 2 b equals to 1 minus alpha. Okay, so why 1 minus alpha over 2 and alpha over 2? Because this one is a skewed distribution. So let's say if you have a normal Z and also T distribution, that one is asymmetric. So that's why we have minus Z alpha over 2 and also Z alpha over 2. Okay, so the same thing for T. Minus T alpha over 2 and also T alpha over 2. But for skewed distribution, chi-square and also the next one is F distribution. That one is a skewed distribution, so it should have chi-square 1 minus alpha over 2 and chi-square alpha over 2. There is ini the things that you need to know lah ya. Okay, there is no okay, ini tak ada. Okay, ini tak ada. So there is no negative chi-square alpha over 2 degree of freedom n. Okay, we just have chi-square 1 minus alpha over 2 and also chi-square alpha over 2 for skewed distribution. Okay, next you want to construct your confidence interval for variance. Okay, so again, the same concept, you modify and then you rearrange the inequality. Okay, let's say we take summation xi minus mu square over sigma square less than chi-square alpha over 2. Okay, sorry. Ni letak n terus degree of freedom. Okay. So again, you want to have here is just summation xi minus mu square over chi-square alpha over 2n. So this one less than sigma square. Okay, katakan 1a. So same thing, kita ambil the other one. So you will have chi-square 1 minus alpha over 2n less than summation Okay, so again here sigma square less than summation xi minus mu square over chi square 1 minus alpha over 2 n. So katakan this one is 1b. Okay, so the next step, you rearrange back your inequality. Okay, kita susun balik. So that's mean what we have here. Okay, saya terbalik dia punya ni, sorry. Okay, so that's mean okay. So that's mean the next step kamu rearrange balik kamu punya inequality dia. Okay. So kita nak susun, kita nak estimate dia punya population variance. Okay, you want to estimate your interval estimate. Okay, so let's say we rearrange back the inequality. Okay, so rearrange. So it will give you this one, kita ada summation xi minus mu square over chi square alpha over 2 degree of freedom n less than sigma square. So this one you will have summation xi minus mu square over chi square 1 minus alpha over 2 degree of freedom n. Okay, so this is the last formula for confidence interval for a single population variance where your case is mu is a known number. Okay, so kita ada case 1, mu is a known number. Okay, so all this one, your random sample is coming from normal distribution. Kita ada mean mu, variance, sigma square. So the MLE for sigma square, so sigma square hat is 1 over n summation xi minus mu square. Okay, so this let's say we define a random variable y, so summation xi minus mu square over sigma square. So this is your chi square with n degree of freedom. So kita nak construct confidence interval for a single population variance. So replacekan y. Okay, so kamu ada summation xi minus mu square over sigma square. So again, you modify your equation and then you rearrange back your inequality. Then you get the value. Okay, kita ada chi square alpha over 2 and chi square 1 minus alpha over 2. So the values you can refer from your stats table. Okay, so itu case mu is a known number. So from the question, you need to identify whether that one either case 1 ataupun case 2 lah. Kalau case 1, mu is a known number, maksudnya dah diberilah normal atau normal apa dia punya mean. Variance dia sigma square lah because your variance is unknown. You only want to estimate your variance. Okay, so itu the first case. Okay, let us refer to the second case. So second case is case mu is unknown number. This is what we did during your first year. Okay, first year kita consider ini je, mu is unknown number. So ini pun familiar, you already familiar with this confidence interval. Okay, maksudnya di sini, you have unknown mean mu and also variance sigma square. Unknown mean, unknown variance. So when you have unknown mean mu, you need to estimate by using your x bar. When you have unknown population variance, you need to estimate by finding your s square lah. Biasa ini dia punya 1 over n minus 1 summation xi minus s bar square. Okay, so di sini what we have is this chi square distribution. So you have chi square is equals to n minus 1 s square over sigma square. Okay, kalau yang tadi kita ada y dia equals to summation xi minus mu square over sigma square. Okay, so but this one, what you have here, kita dah ada replace mu head tu dengan x bar. Okay, so dia akan jadi di semalah bila kita ada s square tu, this is the formula for your sample variance, which is summation xi minus s bar square over n minus 1. Okay, so that's mean we will replace the value n minus 1 s square over sigma square. Okay, so the same approach. Kamu nak construct for probability 1 minus alpha. So benda yang sama je. Okay, so that's mean you will have here your chi square 1 minus alpha over 2. But now you have a degree of freedom is sorry. Kita ada dia punya degree of freedom adalah n minus 1. Okay, n minus 1 sorry. So kita ada chi-square alpha over 2 n minus 1. Probability is 1 minus alpha. Okay, so you want to estimate this one lah. Okay, so we have probability chi-square between chi-square 1 minus alpha over 2 and chi-square alpha over 2. So the same approach, kita replace and then we do some modification. Okay, so here you have n minus 1 s square over sigma square less than chi-square alpha over 2. N minus 1 equals to probability 1 minus alpha. So same concept. First, kamu tengok bahagian sini dulu. Okay, let's say first you consider here. Okay, n minus 1 s square over sigma square less than this one. So sigma square bawa ke sana. Yang ini bawa ke bawah. So kita dah ada n minus 1 s square over chi-square alpha over 2 less than sigma square. Okay, second, you refer the second one. So let's say, okay, you refer. Okay, so you refer this one. So the same thing. Okay, ini bawa naik ke atas and then rearrange back. Then you get your confidence interval for sigma square. So case dia when you have unknown population variance and also unknown mean. Okay, maksudnya kita kena estimate, kita kena dapat value of x bar. Baru kita boleh selesaikan this one lah. Confidence interval for a single population variance. Okay, dua benda sama ada mu is a known number, mu is unknown number. So refer baca soalan tu betul-betul. Tengok sama ada yang diberi tu, is it a known number or unknown number. Okay, then you know how to decide whether you want to use ataupun construct this confidence interval ataupun the other one. Okay, but again, both are skewed distribution. So that means probability is just 1 minus alpha. Okay, probability dia. Okay ke? Okay, so that one is this one So, okay. So macam mana kita nak consider whether that one is known number or unknown number. Okay, let's say we refer to this example. Okay, a random sample size 10 from a normal distribution. You have mean 0 variance sigma square. So yields this value. Determine a 95% confidence interval for sigma square. So sebelum tu mungkinlah kita dah derive dia punya confidence interval. And then given this distribution, akan dapatkan dia punya confidence interval. So is it case 1 or case 2? How you want to determine that one? Case 1 ke case 2? Anyone? Macam mana kita nak consider that one? Okay, Fazlin jawab case 1. Yang the rest? Apa pandangan kamu?
Case 1.
Case 1 ya. Reason? Justification dia apa, Iman?
Okay.
Macam mana kita tentukan?
Tentukan.
Yalah, macam mana kamu decide lah case 1 ataupun case 2?
Okay.
Sorry. Boleh?
Sebab ada nilai min ke?
Ya betul. Okay. So sekarang ni kita dah ada ni. Sebab hari tu kan saya suruh kamu identify juga. So that's mean this one ni. Keywords here. Okay, bukanlah keywords. Macam mana kita nak identify. So you have case here is normal, mean 0, variance sigma square. So mean 0 tu maksudnya a known number. Dia dah tulis siap-siap kat sini dah. Okay, mean 0, variance sigma square. Yang kita tak tahu adalah sigma square. Okay, sigma square is unknown. So katakan kalau saya tulis macam ni, normal, theta 1. Kalau case ni, Case apa yang unknown? Apa yang unknown?
Case sigma square non.
Sigma square 9 betul. Okay. Because parameter unknown parameter kamu ni theta. Ini kamu case punya sigma square dia is known lah. So kalau macam sigma square is known, katakan taburan apa? Confidence interval for mean. Okay, for mean. Okay. So you can identify whether there's one kita memang kita nak estimate parameter mu ataupun saya tulis macam ni lah, normal mu 1. So it can be ideal case sigma square is known. Kalau saya tulis mu sigma square, that mean both parameter are unknown lah. Okay, so kamu refer lah. Kadang-kadang mungkin kita tulis mu sigma square, tapi adalah sentence tulis with sigma square is known. Maksudnya population variance diketahui dan case dia mungkin case 1 lah. Sebab kalau dalam one sample mean tu, case 2 and case 3, both population variance are unknown. Okay, so that is how you want to justify. Okay, daripada soalan tu je. Okay, daripada kamu punya derivation tu, soalan asal tu apa tengok balik. Okay, now kita nak selesaikan. Okay, random sample size 10, okay, yields this value. Okay, determine a 95% confidence interval for sigma square. Okay, so we already know this one is your case here, yang ni. So again, your mu here is 0. Okay, mu is 0 Kita ada summation xi minus mu square. So since your value summation xi, okay, so samalah kalau kita gunakan ini je. Right? Summation xi square. So ini dah ada, which is 106.6 sebab mu tu 0. Okay, so kamu perhatikanlah. Okay, again, apa kita nak cakap tadi? 95% confidence interval. So kamu perlukan value chi-square, boleh dapatkan daripada table tak? Chi-square alpha 0.05, so divide by 2. So 0.025, degree of freedom 10. Ini jangan salah ya. Chi-square, kadang-kadang benda tu dah betul, cuma kamu punya degree of freedom. So baca table salah lah. Okay, degree of freedom n saja. Sebab dia adalah case 1. Okay, ini formula asal kamu. This one. Bukan n minus 1. Kalau n minus 1, for the other one lah, for this one. Mu is unknown number. Okay, chi-square 0.025 and chi-square 0.975. Cuba refer pada stats table.
$20.483 ke doktor?
Okay, yang 0.025 kah? Kan? 20
Ya doktor.
483 satu lagi. Cuba tengok 0.975. You all punya table lama ke table baru lah? Table yang ada formula ke? Lupa.
Table yang lama doktor.
Table yang mana?
Table yang lama.
Yang tak ada list of formula kat depan tu. Tak ada.
List of formula.
Tak ada Ni warna apa? Warna apa table you all? Power dia warna apa?
Kalau lama warna pink.
Sekejap, warna pink. Pink tu lah yang Hisham Lee punya ke? Author?
Ya betul. Ashley.
Ya.
Okay, itu Prof Hisham yang kita punya yang bukanlah. Taklah suruh beli sebab dah final year kan. Yang terbaru kita dah ada formula lah kalau mungkin. Yang third year saya tak pasti. Third year kau pakai yang mana? 3 SSCM? Siapa ada? Ni siapa 3 SSCM? Hani. Dia tak Hani.
Yes, doctor.
Which stats table that you use?
The brown book.
Pardon?
Brown color book.
Brown? Maroon. Is it maroon?
It says 2019 one.
Okay. The author is it still Hisham Lee or us? Us, I mean all the lecturer lah.
Yeah.
Okay.
That's your name there.
Okay. So yang the latest tu kita ada 10 orang punya nama tu. Okay, mostly all the lecturer yang ajar statistik lah. So itu kita exclude Prof Hisham Lee. Prof Hisham Lee sebab dia dah ke atas, kita level bawah lagi. So kita buatlah statistical table yang baru. Okay, so that one you can get from Shopee sebab dah ada Shopee kita through publisher tapi it's quite expensive lah sebab ini selalu sebab dah ada copyright and also publisher lah for that one for stats table tu. Okay, so back for this one. Again, so you have 0.025 and 0.975. So this is the value from your stats table. So kita just substitute balik lah. Okay, we already have the formula. Okay, so okay, so you have this formula. So again, you have summation as I square. So we just replace back. Okay, so that's mean 106.6 divided by 20.483 less than sigma square less than 106.6 and then 3.247. Okay. And then kamu bagilah jawapan dalam bentuk at least 3 or 4 decimal point Okay. Kalau betul-betul 2, kalau dia memang tak ada 0.9, katakan 0.210, so okay lah if you take 0.1. Okay. But if you have another values, so normally use 3 ataupun 4 decimal point. Okay, supaya in marking scheme lah lebih konsisten dan mudah untuk disemak. Okay, for that one. Okay, cuma stats table value from stats table jangan bulatkan ambil keseluruhan value dia. Okay, janganlah kamu bulatkan 20.48 pula, terus ambil 20.483. Okay, so because we use that value. Okay, so kalau tidak saya kena check one by one. Okay, if you round to the nearest value. Okay, so that one is a random sample of size 10 from a normal distribution. Okay, macam mana kita nak justify ataupun kita nak kenal pasti ini mean 0, variance sigma square. So mean 0 maksudnya mu is unknown, dah diberi daripada soalan. Okay, yang tak tahu adalah kamu punya sigma square. So you want to estimate your sigma square. Okay, for that one Okay, let's say we refer to this one. Okay. Okay, so if you check the question, it's quite different. Okay, first you have assumed that the time in days required for maturation of seeds of a flowering plant X is mu X sigma square X. Okay, dia diberi macam ni. Okay, so in this case you have your mu is unknown number. Kita ada X bar. Okay, and then sigma square X is also unknown number ataupun unknown parameter. So you have your S square. So random sample size 13. Okay, so construct a 90% confidence interval for sigma square. So the same thing here. Okay, cuma kita ada this one lah. Kita ada formula dia n minus 1 S square over chi square alpha over 2 n minus 1 less than sigma square n minus 1 S square over chi square 1 minus alpha over 2 n minus 1. So this is the formula. Okay, kita go back here. Ini. Okay. So now dapatkan the same thing. Okay. So alpha 0.1. So dah baca So chi square alpha divided by 2. So 0.05. N minus 1 So 13 minus 1, 12. You get this value. Chi square 0.95. Degree of freedom 12. Okay. So you will have 20. Check saya punya ni. 21.02. 61. This one 5.2260. Okay, and then you substitute. So again, ini tak ada apalah. 13 minus 1. S square 10.7. Already square. Tak perlu squarekan lagi. Kalau diberi sample standard deviation, yes, you need to square the value. Okay, so chi square 0.05, which is 21.0261. Less than sigma square, less than. Okay, divided by 5.2260. Okay, so give the value. Apa dia punya lower limit, apa dia punya upper limit dia. Okay, so that one is your confidence interval for population variance. Okay, case unknown number, unknown parameter mu and also unknown population variance. So sigma square kita estimate lah. guna n minus 1. So n minus 1 s square over chi square alpha over 2, n minus 1 less than sigma square less than n minus 1 s square over chi square 1 minus alpha over 2, n minus 1 degree of freedom. Okay. Okay, ada apa-apa pertanyaan? So this one is confident interval for a single population variance law. Okay, make sure you know how to derive. Okay, how to derive and then distinguish lah dia punya soalan tu. Okay, for that one. So okay. Ada soalan ke? Tak ada, saya proceed dulu.
Tak ada, Doktor.
Okay. So again, sekejap ya, saya